about derivatives. So I'm just going to write that real quick. DERIVATIVES. First, I think. So, this concept makes a lot of people get confused and stuff because it's really complicated, but I don't want you to be like that, so I'm going to break it down for you. So we have a coordinate plane. Then we're going to draw a slope, maybe? Yeah, a curve. And if you zoom in really close to the curve, you'll find a line. Like, you should zoom in really, really close, like microscopic close. So that's what happens when you zoom in. And if we want to find a slope which has a value assigned to it, I'm going to do that real quick. Yeah, I'm going to enlarge it. So if you want to find, like, it has a number corresponding to it. So if you want to find out what that number is, there are different formulas and different equations you can do. So we do d over dx, or any variable, I just put like dx, equals to the symbol used to derivate, or I'm not sure that's a word, but, or take the derivative. And that's what that symbol is. So let's take an example equation. So right now, the example would be d over dx of f of 2x squared. So this is just an example, but that would evaluate to 4x to the power of 1, or 2 multiplied by 2x to the power of 1, which is also known as 4x. And if you don't understand this, I can explain it. So you should have a good understanding, but it's called the power rule. You should have a good understanding of calculus. So this is the basics of it. So the power rule. So let's say we have a function d over dx, and then we have f of x. Or, yeah, let's just take the equation. So the things that I'm circling are really important. So to use the power rule, you need to have a multiplier, a variable, and a power. If you don't have a multiplier, then you can just put 1. So you take the multiplier, put it at 2, that we multiplied by. The multiplier is the one that you do multiplying by. The power is also called n. And we have n of x to the power of n minus 1. So n of x is just 2 multiplied by x, which is just 2x. So then we have that to the power of 2 minus 1, which is 1. Then we just multiply all by 2, which equals to 2x multiplied by 2. Let me just write that down. 2x multiplied by 2, which equals to 4x. That's the answer to that. So if you're wondering, like, this is just if. The opposite of derivatives are known as integrals. And there's maybe I can explain it, but I'll give you an example equation. The integral of x squared with, of course, respect to x. So a lot of people just, you have to give respect to, I don't know why, but you have to give, like, respect. You have to give respect to all math, but I don't know why, though. You just have to give respect to it. So, we need to have, like, a range if you want to do a definite integral, so that's what we're going to be talking about. And we have x squared, and we're going to put a range between 1 and 2. So the first things that we're going to do is, what's x? If x was 2, then it's going to be 2 to the power of 2, right? Correct me if I'm wrong. Then we have to minus, if x was 1, then it would be 1 to the power of 2, which equals to 4 minus 1, which equals to 3. So the answer to that problem is 3. So that's basically the basics of, like, derivatives. And I'm just going to explain how integrals work now. I forgot to do that. So if we add a line, a curvy line, onto a coordinate plane, then we're going to have a range 1 to 2. Then we need to find the area underneath the line. So the area underneath the line would be equal to the answer we got. And since the answer we got is 3, the area underneath that curve from 1 to 2 is, one second, let me just draw that. Yeah, and yeah. The answer to that would be 3. And that's the basics.